You are warmly welcome back to GordMaths. This is where mathematical literacy begins. In today's lesson, we will look at how to rationalize sets and a few applications of sets. If you have not hit the subscription button yet, please do, and stay tuned for more interesting lessons from GordMaths. Let's get started with today's lesson. In simplifying fractions involving sets, it is always preferable to get an answer which does not have a set at the denominator. To do this, we multiply both the numerator and the denominator of the fraction by a certain number that will rationalize the denominator. Rationalize the denominator means we should make sure that the set at the denominator is removed. Let's consider a set of the form root a divided by root b, where we have a square root at the denominator. The idea of rationalization is to remove this square root. In our previous lesson, we learned that if we multiply the square root of a number by the square root of the same number, then our answer is equal to that number. So in rationalizing this denominator, we should multiply the denominator of the fraction by square root b, so that the square root will be removed at the denominator. But we do this by finding equivalent fractions, which means that we multiply both the numerator and the denominator by the same number. And this is going to give us square root of a times square root of b gives us square root ab. And then the square root of b times the square root of b gives us b. Once there is no square root at the denominator, it means the set or the expression here has been rationalized. Let's consider a few examples. 2 square root 3 divided by root 2. That is our example I. Then example II, we have 4 over square root of 5. Then example III, we have root 3 divided by 2 times square root of 2. Let's consider these examples where we want to rationalize the set by eliminating the square roots at the denominator. For the first example, I, we have 2 square root of 3 divided by square root of 2, where we know that to eliminate square root of 2, we must multiply both the numerator and the denominator by square root of 2 to obtain an equivalent fraction which is the same as this. Then we multiply 2 square root 3 by square root of 2. And then at the denominator we have square root of 2 times square root of 2. This will give us square root of 3 times square root of 2 will give us square root of 6. Then since this is 1 root 2, 2 times 1 also gives us 2. Divided by root 2 times root 2 will give us 2. Since we don't have a square root at the denominator, this set has been rationalized. Consider the second example, where we have 4 divided by square root 5. Since we have a square root at the denominator, this expression needs to be rationalized. And we rationalize by finding the equivalent fraction. And this gives us 4 times square root 5 will give us 4 root 5. And then square root 5 times square root 5 will give us 5. There is no more radical at the denominator, and so this set has been rationalized. Let's take the last example, where we have square root of 3 divided by 2 square root of 2. In finding the equivalent fraction, we multiply both the numerator and the denominator by 2 square root of 2, which is the number we have as the denominator. This will give us, this is 1 root 3, so 1 times 2 gives us 2. And then square root of 3 times square root of 2 will give us square root of 6. Over here, 2 times 2 will give us 4, and then square root of 2 times square root of 2 will give us 2. And this, we will have 2 root 6 over 4 times 2 is 8. This can further be simplified when we divide both sides by 2, or when we divide through by 2. 1 root 6 is the same as root 6 divided by 4. You would observe that in each of these examples, the denominator contains only a single term. We will consider examples where we have the denominator that has more than one term. Suppose we have the expression a over 3 plus square root of b, or we have the expression square root of c over a plus square root of d. And we want to rationalize these sets where we want to eliminate the square roots at the denominator. In this case, we multiply both the numerator and the denominator by what we call the conjugate of this denominator. The conjugate of a set is obtained when we change the sign between the given terms. And so the conjugate for this set is 3 minus square root of b. And then the conjugate for this set is a minus square root of d. If we consider another example, say 2 root 5 plus 1, all divided by square root 3 plus 2, then the conjugate for this denominator is square root of 3 minus 2. So we obtain the conjugate when we change the sign between the terms. We could also have 1 over a minus square root of b, and the conjugate for this is going to be a plus square root of b. These are what we call the conjugates of the sets. Now we will take examples which involve denominators that have more than one term and look at how we can use the conjugates to rationalize these expressions. Looking at these examples where we have more than one term at the denominator of each expression, and we have already discussed that in rationalizing these sets, we must multiply both the numerator and the denominator by the conjugates of the denominator. And the conjugate for this is 1 plus square root of 3. We call this conjugate. The conjugate for this denominator is 2 minus square root of 2 minus 4. So, in rationalizing this set, taking the first question where we have 2 over 1 minus square root of 3, we multiply by the conjugate, which is 1 plus square root of 3 over 1 plus square root of 3. This will give us an equivalent fraction. So let's solve this. 2 is multiplying the whole of this. So we have 2 in bracket 1 plus square root of 3. Then at the denominator, we have 1 minus square root of 3 multiplying 1 plus square root of 3. And this should give us 2 times 1 is 2. 2 times square root of 3 will give us 2 square root of 3. Then at the denominator, we want to expand this bracket. So 1 here will multiply the whole of this expression, 1 plus root 3. Then minus root 3 will also multiply the whole expression, 1 plus root 3. Let's simplify that. We will have 2 plus 2 root 3 at the numerator. Then at the denominator, 1 times 1 will give us 1. 1 plus 1 times root 3 will give us root 3 or 1 root 3. When we come here, negative root 3 times 1 will give us negative root 3. And then negative root 3 times root 3. That is going to give us negative 3. We have already learned that when the square root of a number multiplies the square root of the same number, the answer is that number. So finally, we will have 2 plus 2 root 3 divided by, we know that positive and negative numbers that are equal cancel out. So plus root 3 minus root 3 gives us 0. Then at the denominator, we'll be left with 1 minus 3, which will give us 2 plus 2 root 3 all over negative 2. Once we have no set at the denominator, we have rationalized this expression. Let's consider the second example. Example B. We have 3 root 5 over root 2 plus 4. We have already identified the conjugate for the denominator, and so we multiply by that conjugate, which is root 2 minus 4 divided by root 2 minus 4. And that should give us, we have 3 root 5 multiplying the whole expression root 2 minus 4. Then at the denominator, root 2 plus 4, which is this, will also multiply the other expression root 2 minus 4. Then let's expand the brackets. We have 3 root 5 times root 2. Since this is 1 root 2, we will have 3 times 1. Then at the square root, root 5 times root 2 gives root 10. Then 3 root 5 minus 4, 4 will multiply the number, that gives us minus 12 root 5. Then at the denominator, let's expand. Root 2 will multiply root 2, that gives us 2. Root 2 will multiply negative 4, that gives us negative 4 root 2. We have already discussed the multiplication of sets. Then from there, plus 4 times root 2 will give us plus 4 root 2. And then plus 4 times minus 4 will give us negative 16. So from there, negative 4 root 2 and then positive 4 root 2 will cancel out to give 0. Then we will come to 3 root 10 minus 12 root 5 all over 2 minus 16. That gives us negative 14. Note that once there is no more radical at the denominator, this expression has been rationalized. And we'll take a few more complicated examples. So for the first question, let's do our solution here. We have 2 plus root 5 over 3 minus root 5. And we know that is equal to, let's find the conjugate of this set as discussed in our previous example, and that will be 3 plus root 5. So we multiply both the numerator and the denominator by 3 plus root 5, 3 plus root 5. This will give us an equivalent fraction. Then let's do the expansion. 2 plus root 5 will multiply 3 plus root 5. And then 3 minus root 5 will also multiply 3 plus root 5. Let's do the expansion here. 2 times 3 gives 6, plus 2 times root 5 will give us 2 root 5. Then root 5 times 3 will give us 3 root 5. And then root 5 times root 5 will give us 5. Divided by, at the denominator, 3 times 3 is 9. Then 3 times root 5 is positive 3 root 5. Negative root 5 times 3 gives negative 3 root 5. And then negative root 5 times root 5 will give us negative 5. And this should be equal to, here we have like sets, that is sets with the same number under the square root sign. So we put them together and then we put the whole numbers together. 6 plus 5 is 11. Then this will give us 5 root 5 divided by, here 3 root 5 minus 3 root 5 is 0. So we'll be left with 9 minus 5, and that gives us 4. Since there is no more radical at the denominator, this expression is rationalized. And then we take the second example, where we have 1 plus 3 root 3 over 2 minus 2 root 3. We multiply this by the conjugate of the denominator, and that is 2 plus 2 root 3. Then let's do the expansion here. We would have 1 plus 3 root 3 multiplying 2 plus 2 root 3. And then 2 minus 2 root 3 will also multiply 2 plus 2 root 3. Let's do the expansion here. We will have 1 times 2 will give us 2. 1 times 2 root 3 will give us 2 root 3. Then 3 root 3 times 2 will give us 6 root 3. Since it's a whole number, it multiplies the whole number. Plus 3 root 3 times 2 root 3. 3 times 2 will give us 6. And then root 3 times root 3 will give us 3. Divided by 2 times 2 is 4. 2 times 2 root 3 will give us 4 root 3. Whole number multiplies whole number. Then negative 2 root 3 times 2 will give us negative 4 root 3. Then negative 2 root 3 times 2 root 3. Negative 2 multiplies 2, and that gives us negative 4. Root 3 multiplies root 3, and that gives us 3. So we would finally have 2 plus, since these are like sets, we put them together, we have 8 root 3 plus 6 3 is 18, all divided by 4 root 3 minus 4 root 3 will give us 0, and we will be left with 4 minus 4 times 3 is 12. This will give us 2 plus 18 is 20 plus 8 root 3, all divided by 4 minus 12 gives us 8. Now you'd realize that each of the terms is an even number. And so if we want to simplify further, we can divide through by the even number 4, which can divide each of this. And 4 minus 12 is rather negative 8. So we divide through by 4. 4 divides 20, and that gives us 5. Plus 4 divides 8, that gives us 2 root 3. And then when 4 divides this, we have negative 2. We would also look at a few applications of sets. There are some equations that involve sets. There are other instances where, for example, the sides of a triangle or a rectangle are given in set form. How do we deal with such expressions? Let's consider, for example, an equation that involves sets. Taking the example x plus 2 root x plus 1 is equal to 7. How do we solve this equation? First, we must make sure that only the set is at one side of the equation, then the other variables move to the other side of the equation. So in rearranging this equation, we will have 2 square root of x plus 1 is equal to 7 minus x. In removing these square roots, we must square both sides of the equation. So next, we will square both sides of the equation. That is in an attempt to remove the square roots at the left-hand side. And squaring the equation means we multiply 2 root x plus 1 by itself. Then we multiply 7 minus x by 7 minus x. Then, how do we simplify this? In multiplying sets, we know that the whole numbers multiply. That is 2 times 2 gives us 4. And then square root of x plus 1 times square root of x plus 1. The square root of a number multiplying itself gives us that number. Like for example, square root of m times square root of m gives us n, as in our previous examples. Then this will also be equal to 7 times 7 is 49. Then 7 times negative x is negative 7x. Negative x times 7 is negative 7x. And then negative x times negative x will give us positive x squared. Then expanding the bracket at the left hand side, we have 4x plus 4 giving us 49 minus 7x, and then minus 7x will give us minus 14x, then plus x squared. Let's put like terms together. We have 4x at that side, so we send it there, and then we have 49, we send this one to there. And then since this is a quadratic equation, it must start with the highest power. So x squared, then minus 14x. We are moving this to that side of the equation to become minus 4x. Then we have a positive 49 here. Then we move 4 to the other side to become negative 4. So this side will be 0. Then we will have the quadratic expression x squared minus 14 and minus 4 will give us minus 18x. Then 49 minus 4 will give us 45, and that is equal to 0. We have just made a rearrangement. So we solve this quadratic equation, and you can always refer to our lesson on quadratic equations for this. So we will solve this quadratic equation for the values of x, and that we have x squared minus 18x plus 45 is equal to 0. So we have x squared. In simplifying this, we will have minus 3x minus 15x. Those are the factors of 45, which when we add, we will get 18x is equal to 0. We have plus 45 equal to 0. So x, taking this side, x outside, we will have x minus 3. That is when we factorize x out. Then here 15 is a factor in both terms. So minus 15 comes out. Then we will have x minus 3 equal to 0. So finally we will have x minus 3 and then x minus 15 equal to 0. So x minus 3 equal to 0, x minus 15 also equal to 0. And we will have x is equal to 3 and then x is equal to 15. So the value for x in this expression is x equal to 3 or 15. You can refer to our lesson on quadratic equations if you have any problem with this. We will take just one more application of sets. We will take this last example on the application of sets. The diagram below is a right angle triangle, and then we want to find the value of x. We should know from basic mathematics that in a right angle triangle, the square of the hypotenuse, which is the longest side, is equal to the square of the two other sides added together. So we would have the square of the hypotenuse, which is 2 plus 4 root 3, is equal to the square of the two other sides. This is called the Pythagoras Theorem. And we want to find the value of x from this. So, since we want to find the value of x, let's move the other term to the left hand side, so that we will have 2 plus 4 root 3 all squared minus 4 plus 2 root 3 squared is equal to x squared. We want to find the value of x. Let's do this expansion. That is 2 plus 4 root 3 and then 2 plus 4 root 3 minus, for this we will have 4 plus 2 root 3, 4 plus 2 root 3, and that should be equal to x squared. 2 times 2 is 4. 2 times 4 root 3 gives us 8 root 3. 4 root 3 times 2 also gives 8 root 3. Then 4 root 3 times 4 root 3, that will give us 16 times 3. 4 times 4 is 16, and this is 3. Minus the negative affects all these, so we will put that in brackets. 4 times 4 is 16. 4 times 2 root 3 will give us 8 root 3. 2 root 3 times 4 will still give us 8 root 3. Then 2 root 3 times 2 root 3, that will give us plus 4 root 3 times root 3 is 3, equal to x squared. Then in simplifying this, we will have 8 root 3 plus 8 root 3 is 16 root 3. Then 16 times 3 is 48, minus, we have 16. 8 root 3 plus 8 root 3 gives 16 root 3. Then 4 times 3 is 12, and that is equal to x squared. So we put this together to have 52 plus 16 root 3 minus, here 16 plus 12, we have 28 plus 16 root 3, and that is equal to x squared. We expand the bracket here, so we have 52 plus 16 root 3 minus 28 minus 16 root 3, since the negative affects everything in the bracket. And that is equal to x squared. 16 root 3 minus 16 root 3 is equal to 0. So we will be left with 52 minus 28. And that is equal to our x squared. 52 minus 28 should give us 24, and that is equal to x squared. So if we want to find the value of x, we take the square roots of both sides. Squared cancels square roots, and finally our x will be equal to square root of 24. Remember that square root of 24 is not in the simplest form, so we have to reduce it to the simplest form. 24 is 4 times 6, so that gives us 2 root 6, and that is the value of x from the right angle triangle below. This example brings us to the end of our lesson on sets. I believe you have enjoyed this lesson, and you will hit the subscription button for more interesting lessons.